the integrated 3.2.4 notes. Now we're actually going to get into some trigonometry. So the tangent ratio. So what we've been working on so far is actually building up to this. The tangent ratio is actually the same as the slope ratio. So if we take a look at the picture itself, notice that the sides are identified based off of that angle theta. So starting from theta, if we go across, we know that this would have been the rise. And right next to it would have been the run. Now I'm going to change it. I'm going to be a little bit more specific with this so I don't necessarily have to be in a graph. We're going to talk about this rise as the opposite side of the angle. And we're going to refer to the run as the adjacent side of the angle. This ratio that actually compares the rise over run, so slope, which also compares the opposite to the adjacent, this is called the tangent ratio. This is going to be our first of 3 trigonometries that we deal with this class. So we'll know what the tangent ratio is of the triangle. All right, so it's the same idea as identifying the slope triangle. So start at the identified angle. In this case, I would say that that identified angle is theta. Notice that we will not be using the 90-degree angle, and I'm not going to use the unmarked angle. So we're going to go across to find the opposite side. And then we want to find this side that's right next to it that is not the hypotenuse. That is going to be the adjacent side. So what I can say is that the slope ratio is equal to 4/3. We can also identify this as the tangent ratio. So we are going to say tan of the angle specifically. In this case, it was theta. And we're going to use the same ratio of 4/3. That's our answer for this one. So we're moving away from this idea of slope ratio to being able to find the tangent ratio. Now, on B, we don't have an identified angle, so this would have been given to you. So let's put the theta up in angle A. So we'll go through and do the exact same thing. So start at the identified angle, go opposite it, and identify the opposite side, which would have been the rise. And then we want to go to the side that's right next to it that is not the hypotenuse. This is the adjacent. So what I could say is that the slope ratio, again, we're moving away from this, so the slope ratio would have been 24/18. But if we rewrite this, this is tangent of the specified angle theta would be 24/18. That would be our answer. So our ratio is going to be the 24/18. You could simplify it if you'd like to as well. Okay, so now we're actually going to solve for the angles themselves. So to do this, we want to talk about the indicated variable. Well, we've got a couple of them. I would say that let's just solve for the 40 at this point. So not solve for the 40, but I'm not going to be using the theta at this point. So I'll come back to this in future notes and we'll figure out what that theta is, which we could because of triangle sum. But for right now, I just want to start on that 40. So we're going to go opposite that 40 degrees. I'm going to identify this as the opposite side. And we want to go right next to the 40 degrees, not the hypotenuse, and identify that as the adjacent side. Okay, from here, let's go ahead and set up our tangent ratio. So it's going to be tangent of our angle, 40 degrees. The opposite side is 7, and the adjacent side is x. Okay, now we actually need to solve this. The only variable in here is x. Tangent of 40 is a numeric value. So I'm going to actually put a 1 underneath this and cross multiply. This is going to give me x times tangent of 40 degrees is equal to 1 times 7. Okay, so that's x times tangent of 40 is equal to 7. Now tangent of 40 is just a number, so we're going to divide both sides by tangent of 40. I know that a number divided by itself cancels. This becomes 1. So my exact answer is going to be 7 divided by the tangent of 40. However, this doesn't really mean much to us. So at this point, you would want to use the scientific calculator that you either have yourself or I have linked. And what we're going to do is we're just going to type it in exactly as we see it. So we would do, and this is going to be an approximation. So in your calculator, you want to do 7 divided by, now I recommend using the scientific calculator that I have linked because then we can use the fraction option. So I'm going to do 7 divided by, and then you'll see also on that calculator that's linked, there is a button that says tan. Go ahead and push that tan button, and then it should open a set of parentheses for you. If it doesn't, open a set of parentheses yourself, and we want to put the 40 inside those parentheses. So I would have 7 divided by tan 40. If I type this into my calculator, I will then get approximately 8.3422. This is our approximate answer. We do want to make sure that this makes sense though. So let's go back to the picture. So we're saying that this adjacent side is approximately 8.3422. Let's notice how it compares to the other side. So we know the longest side in the right triangle is going to be the hypotenuse, which is the unmarked side. But then we want to take a look at the other two angles, or the other two sides as well. So let's compare the 7 and the 8.3422. Notice the 40-degree angle inside the triangle is opposite the 7. Well, if we were to go through and do triangle sum, so we may as well actually do that while we're here. If we went through and we did triangle sum, like we had done previously, then we would know how big angle theta is. Because we know if you add all 3 of the angles inside this triangle, you're going to have to get 180. So this angle up here is going to have to be 50 degrees to satisfy triangle sum. So, looking back at the angles, notice that 40 degrees is the smallest angle in this triangle, which means the side opposite the smallest angle, 40, must be the smallest side, 7. Additionally, if we take a look at that 50-degree angle and we looked opposite it, the 50 is the medium-sized angle, so the 8.3422 should be the medium-sized side. So, does it make sense? Yes, it absolutely does. Okay, let's move on to question number, or part B. We're going to do the same thing here. So, from the 6 degrees, we need to identify our sides. So, start from the 6, we're going to go opposite it. That's going to be our opposite side, was the 3 feet. Then we want the side that's right next to the 6 degrees, but not the hypotenuse. That's the adjacent side. And we're going to plug it into the ratio. So tangent of the angle, 6 degrees. Opposite 3 over adjacent x. Notice that the setup looks a lot like the previous question. So I'm going to put a 1 underneath this as well. I'm going to cross multiply. X times tangent of 6 is equal to 1 times 3. So x times tangent of 6 is equal to 3. Tangent of 6 is just a number, which you can type in and see that it's just a numeric value. I know that tangent of 6 divided by itself is going to simplify and become 1. So my exact answer is 3 divided by tangent of 6. Let's go ahead and get the approximate. So let's type this into the calculator. Again, I recommend using the scientific calculator that I have linked. So I do 3 divided by tangent of 6. Watch those parentheses. This is going to be 28.5430. So there is our approximate answer. Do a quick check and make sure that this makes sense in the picture. So looking back at the picture, let's see, the 6-degree angle, hands down the smallest angle in here. The other angle, using triangle sum, is going to be 84 degrees. So this top angle by the 3 is 84, which means this side, x, is going to be considerably longer than the 3. Still not the longest side. That's the hypotenuse. Okay, why don't you see if you can set up C and then come back and check. Okay, so here's the setup of the equation. We went through and identified opposite 65 that gave me y, and the adjacent was 6. Notice the setup is a tiny bit different, not a huge amount though. I'm going to do the same thing. I'm going to put a 1 underneath. But when I cross multiply this time, I will already have y by itself. So I don't really have to do a whole bunch more work with this one other than just type it in. So the exact answer for y is 6 tangent of 65. Then this is going to be 6 times tangent of 65. Notice we're multiplying this time and we're not dividing. So the approximate is going to be 12.8670. Looking back, does it make sense with the question? Well, 65 degrees is going to be considerably larger than the other angle, which I think up there is going to have to be 25 using triangle sum. So opposite the 25, 6 needs to be the shortest side. So the 6 needs to be smaller than the value of y, which it is. So I think it works out.